Hey guys, it's Jacob from RoboFlow. Have you ever wondered, can a computer tell the difference between a daisy and a dandelion? Well, today we put those philosophical musings to the side and we get hands-on with training a custom image classification model to tell the difference between a daisy and a dandelion. Today, in order to do that, we'll be training our custom image classification model in fastai with underlying PyTorch framework, and we'll be using a Resnet34 model. Before we get into the fun stuff, which will be when we dive in to the modeling here and actually writing the code to train our model, the important thing is to nail down our data set. So here you can see I have pictures of dandelions and daisies, and we have about 1,700 of these images. And before we port these into the Colab notebook, which we'll be using for training, we will be using RoboFlow to use data management, pre-processing, and augmentation so we can make sure that our data set is in its best state before importing it into the model and sending it through the model. So here we have our flowers classification data set. This has already been loaded into RoboFlow. You can use this by going to RoboFlow's public datasets and copying the same one if you want to follow along directly with our tutorial. Otherwise, you can go ahead and upload your own data. This is very quick and easy to do if you have your images in a folder structure where each folder has the images class. But there's more details on that in the blog below. So kind of diving into our data set here, we have over 1,800 images. These are all daisies and dandelions. And we've split them automatically into a train, valid, and test of 70-20-10. And you can see here that we have some options where we can basically like add pre-processing options and augmentation options to our data set to make it larger. So here we have some augmentation options that we can do before we make our dataset version. All of these might be of use, but certainly things like rotation, cropping, and blurring. This is all to kind of simulate the ways that your images might manifest themselves differently than they are in the training set. So they might be slightly rotated, they might be slightly zoomed in or out, they might have a different exposure. All these things that you can simulate with augmentations. So in this augmented version, I've made a number of augmentations here. You can see there's crop, rotate, brightness, all these things, and we're generating 5 images per base training image. So this gives us a larger data set, will prevent our model from overfitting, and you can go ahead and take your data in here, make some steps, and then when you're ready, you can go ahead and hit generate to generate a new version. And this will basically send your images into our backend where all the pre-processing and augmentations will happen, and a new version will be formulated for you. So we'll go ahead and give that a second to run here. And when it's done, you'll receive a link which you will be able to port into the Colab notebook, which I have linked below, and you can just import your data in there and everything will automatically match up so you can get right started with training. You don't have to worry too much about the exact way you're going to parse data structures and stuff to get your data into the model. So here we go. We've now got our dataset version created, and you can go ahead and here and you hit show download code, and this will give us a curl link once the files are zipped, and then the curl link is what we can then import into the Colab notebook for dataset load. So here we go. Here's an example of the curl link. The keys are blacked out, but I've already gone ahead and put that into the notebook and downloaded my data. So now we'll just kind of go ahead and jump into the notebook and jump into the training routine. Okay, so now diving in. Here you can see we have this notebook for you, RoboFlow image classification. And in order to train our image classification model, we're going to be using fastai. Fastai is essentially a deep learning framework that sits on top of PyTorch and makes things really quick and easy to use. And if you want to learn more, we've got blogs on that too, so you can go ahead and check out fastai. Okay, we went ahead and installed that. Then we're going to import here from fastai.vision everything. That will give us all kinds of libraries and different codes that we'll need to train our model. Here's a place here where you import your link. So this is where you'll put your dataset link to train your own custom model on your own for your own classes. But I've gone ahead and put mine in there, and we can go ahead and just check right here with data.classes. Well, first we have to set up the dataset. So this loads it into fastai and resizes it to 224. That's the input size for the Resnet model that we're going to be using. And it normalizes it according to ImageNet stats. So Resnet is pre-trained on ImageNet, so you want to make sure that you kind of normalize your images to the same mean and standard deviation that's present there. So now we can go ahead and take a look at data.classes. So here we have Daisy and Dandelion are the two kinds, and we can use this line of code .showBatch to kind of look and make sure that it is indeed the case that our dataset has loaded in correctly into the fastai training framework. So here we can see we've got Dandelion, Daisy, Dandelion. Okay, looks good. Looks like it loaded in fine. Now we'll go ahead and set up our fastai Resnet model. So here you use the createCNN function to load in a model from the Torch Vision library. So actually we'll jump over here real quick and take a look at that. So this is Torch Vision's classification model library. There's all kinds of models here. So this tutorial is really more than just a Resnet34 model. You can use any of these. So you've got Resnet34 here, that's what we're using. But you've also got bigger Resnet models and a little bit smaller ones too. So all these models are pre-trained on ImageNet, so they already have kind of like a broad view of the way to formulate features from pixels. And you can take these pre-trained weights, lift them off the shelf from Torch Vision, bring that through fastai, and then use the training procedure that I'm going to walk through here in the video. But here you go, you got Resnet34, that's the one we're using today. But you can also branch off if you want to do a little DenseNet, little GoogleNet, little MobileNet. These are all options. There's also object detection models in here too, but kind of outside of the scope of today's video. We're just doing classification here. Okay, so we'll go ahead and download that. So now we're actually going to Torch Vision and taking that model down. And we can also visualize our network here by looking at Learn. So this prints out all the different layers that are in our model. So pretty nice, right? You don't have to build that on your own. The researchers have already done that for you and posted to Torch Vision. So stand on the shoulders of giants, download it, and let's get going. Okay, so now we're going to go ahead and jump into training. There's two things that I'm adding here into training that I think are quite useful, you know, rather than just the plain off the shelf. So we've got an early stopping callback. This means that if your model hasn't improved on validation loss for at least 20 epochs, then it's just going to cut off training. So you don't have to worry about running it for too long to make sure that you're getting the best model. The other one is save best model. So based on validation loss, best model that comes out is going to be the one that gets saved, so you can load that back later. Okay, so now moving along, we're going to go ahead and make sure that our device is hitting the CUDA drivers. You can make sure that that's the case by going up here, hitting change runtime type, and making sure you're hitting the GPU there. But yeah, we're hitting the CUDA drivers, and we're going to go ahead and call this method to start training. I have 50 coded into the notebook, but we're just going to do one here for YouTube. So now we just kicked off training. Our data set has been loaded in. It's going to go through, pass through the model. Important to note here that we're training on the frozen Resnet model. So here we're not actually backpropagating through all of the layers, we're just backpropping through the last layer. And that last layer will kind of tune in based on the features that are coming out of the base model. And then we'll move forward and train on the whole network. Okay, so after one epoch, we've gotten a 7.6% error rate. That's pretty good for just one. Obviously, that will continue to go down if you train for more epochs. And here we just load in that best model, and we're going to unfreeze. So unfreeze is basically now we're opening up the network to be backpropagated through all the parameters, not just the last layer. And we're going to find the appropriate learning rate. So the learning rate is, the way to think about it is basically it's the amount that you're actually updating the weights after you get the back propagation signal. And you don't want to set this too high, otherwise you might kind of like branch off, way off the loss function into some unknown land. But you don't want to have it too slow, otherwise your model won't really learn anything with any speed. I have this function here to get your optimal learning rate for you, so you don't have to worry about setting that yourself. And again, here I'm just going to do one epoch, so we're doing one epoch, unfrozen model. Now we're kind of fine-tuning through the ResNet, and there we go. Looks like we got our error rate down even further. Now we're at 6.5%, so model's getting even better. But again, like I said, that should get better with more epochs. I've seen this one go as low as like a 4% error rate or so. Okay, so now we've loaded back in that best model from all our training. Our model has been trained. Here we can go ahead and start to do a little introspection on our model. This plots the confusion matrix, so this kind of shows how the model's getting confused. Looks like it's confusing dandelions for daisies on occasion a little bit more than it confuses daisies for dandelions. That might be for whatever reason that the data is manifesting itself, but that can be useful, especially if you have a lot more classes, to see where the confusion is coming from. Another also nice thing that fastai gives us is it plots the images in our validation set that are the hardest for our model to understand. This can be really useful to just kind of get an idea in your data set if your data is healthy in quality, and just give you an idea what is the model struggling with. So here you can see that we predicted daisy, but this is really a dandelion. And this one is really tough, right? I mean, that hardly looks like a dandelion. It really could be kind of either one. It's hard to tell, so maybe you'd want to actually throw that out of your data set. But okay, now finally, to kind of wrap up, we're going to use our trained model, and we're going to do inference on test images. And this is something that you could deploy into production in an application. So now you have your trained model, you're ready to go. That's all it took, just a few minutes and a little bit of data management with RoboFlow to get a trained classification model with state-of-the-art technology. So okay, there we go. We're seeing inference here. Looks like it's doing all the dandelions first and getting most of them. Dandelions, and paging through here. Oh, there we go. We saw an error there. It was a daisy, but it was supposed to be a dandelion. And going a little further down, we'll get into the daisy area. Yep, here are the daisies. Looks like the model is kind of doing well on inference across all the images in our test set. So now you have a model, and we've trained the computer to understand the difference between daisies and dandelions. If we can do that, what can't we teach it to tell the difference between? So now lastly, just to kind of wrap up the notebook here, we're going to take a look at our saved models. So that's in best Resnet34.pth. So that's a PyTorch model. And you can go ahead and here download that out of Google Colab, import wherever you want. You can put it in your Google Drive, put it in your Amazon S3, keep it on local. You can export it into ONNX. You can export it into TorchScript. You can kind of take this model and deploy it wherever you like. The rest of where the inference happens and how the application is built is up to you. But I hope you learned a lot here in our tutorial on how to train a custom image classification model with Resnet34. And you can take this model wherever you like and make classifications with it wherever you like. And so if you enjoyed today's video, I would be very appreciative if you would subscribe below, and go ahead and check out RoboFlow for your dataset management, dataset pre-processing, dataset organization, and dataset augmentation. And hopefully these techniques will allow you to form some of the best models in the game, and stay tuned for future tutorials. So thanks so much for watching today, and we'll see you again soon.